Okay, so what we're going to go over is some 4.0 examples of mole conversions that you could be asked to do on your 1FA3 test. So the first thing we're going to do with this problem is determine the number of oxygen atoms. So we're going to be looking for number of oxygen atoms in a 3 mole sample of Fe2O3. Okay, so we're going to start by writing down our starting value, which is 3.0 moles. And that's of Fe2O3. All right, so the problem is in last unit we were just given elements. Here we're giving a compound. So the number of formula units or of molecules of Fe2O3 is not equal to the number of atoms of oxygen. So we're going to actually have to do 2 steps here. So what we're going to need to do is we're going to go from moles, and then we're going to convert moles to molecules, also known as formula units if it's an ionic compound. Okay, so formula units to atoms. So it's going to be a 3-step problem, moles to formula units to atoms. So the way that we're going to do this is we have our starting value, we're going to go times and a line. And so the first thing we need to do is go from moles to formula units. So I want moles to go away, so I'm going to put moles on the bottom. And I'm going to try to get to formula units, which I'm going to put on top, so formula units. And so what we're going to look at is that 1 mole is equal to 6.02 times 10 to the 23rd. So that's that Avogadro's number that we learned last unit. Okay, so that's going to get rid of our formula units, but we're not fully done because we haven't gotten to atoms. So we're going to do times and a line again to do our last step. So a formula unit is this whole formula, Fe2O3. That entire formula is a formula unit. So for every 1 formula unit of Fe2O3, okay, we're going to look at the subscripts. So we're looking for oxygen atoms, so we're going to put atoms of O. And in my molecule, or my formula unit, I have 3 atoms of oxygen. So for every Fe2O3, there are 3 atoms of oxygen. So I'm going to multiply this by 3. So for every 1 formula unit, so a formula unit is this whole compound, right? The Fe2O3, there are 3 atoms of oxygen. So now we have this whole thing set up. It's a matter of just putting it into our calculator. So hopefully you can see my screen when I turn this on. Let me angle that. Okay, so the way that I'm going to type this in is I can type this in all one problem. I'm going to do 3 times, and then I'm going to go 6.02. I'm going to hit my second button, and then I'm going to hit E, and then I'm going to type 23 divided by 1 times 3 divided by 1. Okay, I'm going to hit enter. And when I do, this is my final answer. So my final answer comes out to be 5.418 times 10. And then we can see there's a little 24 written right there to the 24. Okay. And then I notice that my starting value only has 2 digits, so my ending value needs to have just 2 digits. So I'm going to round this to a final answer of 5.4 times 10 to the 24th, and that's going to be atoms of oxygen. So there's my final answer. So let's go ahead and we're going to do another one. Okay, so we're going to try another problem. This one, it says determine the number of moles. So we're looking for number of moles required to produce this many atoms of hydrogen. So we're going to be going the other direction of what we did in the previous problem. So I'm going to start by writing my starting value is 5.0 times 10 to the 23rd, and that's atoms of hydrogen, which is H. So I'm going to do my times in a line. And so we're going to be going backwards. We're going to start with atoms. And from atoms, we want to go to formula units. And then finally, we're going to go to moles. So we're going to set this up. We want atoms to go away, so I'm going to put atoms on the bottom. I'm going to put formula units on top. Okay. And so 1 formula unit is going to be this compound right here, C3H8. And we can see that in 1 formula unit of C3H8, we have 8 atoms of hydrogen. So we have 8 atoms of hydrogen in every C3H8. Okay, so we're going to go backwards and we're going to get to our number of formula units. So I'll do this in 2 different steps, just so you can see it done this way too. So we can take 5.0 is what I'm going to enter, second E, and then I'm going to type 23. Then I'm going to type times 1, and then this means divided by, and then I'm going to type 8 for the 8 atoms that are there. I'm going to hit enter, and that's going to give me 6.25 times 10, and then we can see up here it says 22. Okay, and that's going to be formula units. So now I'm going to take this number, 6.25 times 10 to the 22nd formula units of C3H8, and now I want to go to moles. So I'm going to set up my times in a line again, and I'm going to go formula units to moles. I want formula units to go away, so I'm going to put formula units on the bottom. I'm going to moles, and I know that every 1 mole is equal to 6.02 times 10 to the 23rd formula units. So now it's a matter of taking my answer that I have, so I'm just going to keep that, and then I'm going to go times 1 divided by, and then I'm going to type in 6.02 second E 23, and I'm going to hit enter. And I get this answer of a whole lot of decimals, right? I've got 0.10382, so on and so forth. So I'm going to come and look at my starting value way back here at the beginning of the problem, and it has 1, 2 numbers in it, so my answer only needs 1, 2 numbers. So I'm going to round this to my final answer of 0.10, because the 3 tells me to leave the 0 a 0, and that's going to be moles of C3H8. So that's how to do the second problem.